Here we have Chapter 8, Section 3. This is all on acids and bases. We're going to start with the properties of acids. The first and the most obvious property of acids is that they taste sour. Please don't take your average acid and taste it to make sure. We can do this with lemon juice, but that's about it, okay? Don't try this at home. Another property is that it can make a burning or an itchy feeling on the skin, and it ends up donating a hydrogen ion to another substance. So if you remember when we talked about ions, an ion is an atom that either has too many electrons or not enough electrons. Usually an atom has the same number of electrons as it does protons. As soon as that number is different, we call it an ion. So, for example, when HCl, hydrochloric acid, is dissolved in water, the hydrogen and the chlorine separate, and the hydrogen leaves its electron with the chlorine because the chlorine is a stronger atom. It keeps it. So when the hydrogen separates, it's only the proton. It doesn't get to take its electron with it, so it's a hydrogen ion. Now, this hydrogen ion is free to interact with other substances. So it's going to go out and it can make other combinations. Now, in order to know that you have an acid, you need to know the characteristics of acids. Do you want a safe way to test for acids without tasting them? Please find a way to do this. So, if you put some acid on a carbonate, like limestone, it will produce carbon dioxide gas, and you'll know that because it forms bubbles. So a carbonate like limestone has a lot of carbon in its compounds. And if you put an acid on it, the atoms in the acid and the atoms in the limestone compound are going to react, and you've got basically two atoms in this compound and two atoms in this compound, and they're going to react, and these two are going to join up and these two are going to join up. And so you're actually forming the gas as these two things are coming together, forming the gas, and that's where you get the bubbles. Acids will react with most metals, and they will make hydrogen gas bubbles. And if you have a sheet of tin, a lot of people etch into sheet metals with acids. They can actually draw or write or whatever they do with them. When they put the acid on it, it'll actually eat away a layer of the metals, and so you can see that etching in it. And it also bubbles. It makes hydrogen bubbles. And it will turn blue litmus paper red. And this is the easiest and the cheapest way to figure out if it's an acid or not. And I've got lots of blue litmus paper, and we can test them out on stuff. So then we have bases. So what are our properties of bases? Well, they taste bitter if you're allowed to taste them, please. And they feel slippery. Now, soap is a base. And I want you to picture what soap tastes like. It makes you kind of do that face because it's bitter. And I know that you've been in the shower and you're singing too loud and you've tasted soap before. It can accept a hydrogen ion from another substance, which is why acids and bases always go hand in hand, because an acid is giving off a hydrogen ion and a base wants the hydrogen ion. So they interact very well. For example, let's start with something called sodium hydroxide, NaOH. And when we dissolve that in water, the compound separates into sodium ions and hydroxide ions, which is OH negative, which means it's got an extra negative charge. It's got some extra electrons. When you put an acid with all of this, the acid is going to give off a hydrogen ion, which is H+. It wants an electron. You've got OH with an extra electron, and what happens when you put OH with H? You end up with water. So one of the byproducts of putting an acid and a base together is actually making water. We actually call this neutralization, and the notes for neutralization are in a couple of slides. What are the characteristics of bases? Well, when you mix a base with a fatty acid, it produces a soap-like substance. And the stronger the base, the easier it is to do that. In fact, your skin has fatty acids on it, and if you put a strong enough base on your skin, the harsh base will react with the fatty acids in your skin, and that will burn the fatty acids right off. So touching strong bases, really not a good idea. There are a lot of cleansers that are bases, and the better the cleanser, the stronger the base, and so you don't want to touch things like ammonia, things like that. And bases turn red litmus paper blue. It actually looks pink, but whatever. And this is actually one of the ways that we remember which one is which, because bases with a B turn it blue with a B. So if the paper is turning blue, then you have found a base. Then we have the strength of acids and bases. And the difference is that strong acids and bases break apart completely into ions, where weaker acids and bases don't. Now, this is not the same as concentration. If I have a 4% solution versus a 9% or a 20% solution of an acid or a base, that's concentration. I'm talking where it lies on the pH scale. We have a pH scale that lets us know how strong or weak an acid or a base is. Weak acids don't form very many ions in the solution. Lemon juice is a weak acid. It's not going to eat through anything because the acidic part of the lemon juice, only part of the acid goes out and reacts with bases or whatever, and there's a good chunk, a good part of that lemon juice that's left and still remains an acid and doesn't react. So that's not considered a strong acid at all. It's considered a very weak acid because most of the acid does not interact with its environment. The pH scale is what we use when we're trying to measure strengths and weaknesses, and the pH scale goes from 0, which is a really strong acid, to 14, which is a really strong base. And then right in the middle is 7, and that's considered neutral, and pure water is supposed to be a perfect 7. Tap water tends to be a little on the 6 side, but that's depending on where you live and if you're on well water or city water or things like that. And then we get to neutralization, which we kind of touched upon earlier. Acids and bases neutralize each other. So when you get the two together, your acid is going to give off a hydrogen ion, which is H+, and your base is going to give off a hydroxide ion, which is OH-. And when you put the two together, they make water. Now, these two make water, but the other two that are left over, they're also going to combine, and they are called salts. And it's not like table salt. There's a whole category of chemistry that is considered salts, and they are the leftovers of acids and bases when they combine. Anything that's like that are considered salts, because the most common one is this one, sodium chloride. But any other acid and base that gets together, you're going to have two byproducts, water and a salt, not necessarily sodium chloride. So for example, your stomach is feeling sour because you've got too much stomach acids in it, which essentially is hydrochloric acid. You're going to take an antacid, anti-acid, which means not acid, which means it's a base, and that's like Pepto-Bismol. And the base is going to give off OH, which is hydroxide ions, and the acids, the hydrochloric acid that's all naturally in your stomach, is going to give off H, positive hydrogen ions. And now in your stomach you've got water, and you've got not just got water, but you've also broken down the acids that are in there, so your tummy's going to feel better. So, all right, you've got a test coming up on all of chapter 8. I need you to understand the ideas and definitions and the whole big picture of solutions, the difference between solute and solvent, and what a suspension is. I need you to understand concentration and what we're talking about there and how you dilute something. And then this section, all on acids, bases, and what neutral is considered and how neutralization works. Okay? Good luck, and I will see you next time. Take care.